Types of motion, understanding how things move. Let me begin by asking you a simple question. Have you ever seen a car drive by or a bird flying across the sky? This is motion in action. Motion means change in position of an object with time. If something is changing its position as time passes, we say it is in motion. For example, when a person walks, their position changes every second. So that person is in motion. Everything around us moves in different ways. Some things move in straight lines, other in circles, some even move randomly. Today we will learn about different types of motion that objects can have. Now that we know what motion is, let's look at its different types. There are 6 main types of motion. Translatory motion, when an object moves from one point to another. Circular motion, when an object moves in a circular path. Repetitive motion, motion that repeats over time. Then we have random motion, unpredictable motion with no fixed pattern. Then oscillatory motion, back and forth motion around a fixed point. Then multiple motion, a combination of 2 or more types of motion. Let's break some of these down even further. Translatory motion can be rectilinear, which is straight line movement. Then curvilinear, which indicates curved path movement. Circular motion can be rotatory, like a fan blade spinning on its axis. Revolutionary, like the earth revolving around the sun. Repetitive motion includes periodic motion, repeats at regular time intervals, and non-periodic motion which repeats but not at regular intervals. As we go ahead, we will explore each type with real life examples. Let's begin with translatory motion. When every point on an object moves the same distance in the same time, we say that the object is in translatory motion. There are 2 types of translatory motion, rectilinear and curvilinear. Rectilinear motion, this is when an object moves in a straight line. For example, a car driving down a straight highway. Curvilinear motion, this is when an object moves along a curved path. For example, a train moving along a bend in the track or a roller coaster. In both types, the object is moving from one place to another, but the path it takes is what defines the type of translatory motion. Now let's move on to another fascinating type of motion, circular motion. When an object moves in a circular path, we say it is in circular motion. There are 2 kinds of circular motion, rotatory motion and revolutionary motion. Here you can see the blades of a windmill spinning around a fixed point, its center. In rotatory motion, the object spins about its own axis. Common examples include a spinning top, the blades of a fan, or the wheels of a bicycle. Revolutionary motion, this type involves an object moving in a circle around another point. A great example is the earth revolving around the sun, or a satellite orbiting a planet. The object does not spin on itself but goes around another body. So remember, if it rotates on its own point, then we say it is rotatory motion. If it moves around something else, it's revolutionary motion. Now let's talk about repetitive motion. When a motion repeats itself after a specific time interval, we call it repetitive. We can divide it into 2 types, periodic motion and non-periodic motion. Periodic motion. In periodic motion, the movement happens at regular time intervals. The pendulum swings back and forth at a fixed rate. Other examples, hands of a clock. Earth revolving around the sun, rotating fan blades, pistons in a car engine. These motions follow a rhythm, like a song repeating its beat. Non-periodic motion? Some motions repeat, but not at regular intervals. Waves in the ocean go up and down, but they are not perfectly timed. We call these non-periodic, but still repetitive and predictable. So periodic is like a ticking clock, non-periodic is like clapping randomly. Still motion, still repetition, but no fixed timing. Let's look at some examples of periodic motion in more detail. Earth revolving around the sun. It completes one revolution every 365 days, very precise and periodic. But notice, it's not a back and forth motion. Rotating fan blades. Blades spin at a fixed rate. Perfect periodic example. This is also a rotatory motion but repeated regularly. Hands of a clock. Move in a fixed circular path and repeat every 12 hours. Another great example. Pistons in an engine go up and down in a cylinder. This is both periodic and oscillatory. So, an important note for the students, not all periodic motions are oscillatory. For example, Earth's revolution is periodic, but it does not move to and fro. That's why it's not oscillatory, even though it's periodic. Now let's explore a very special kind of motion, oscillatory motion. Oscillatory motion is a to and fro motion of an object about a central or mean position. This kind of motion goes back and forth again and again over time. Imagine pushing a swing. It goes forward, comes back and repeats. This is oscillation. So let me provide you a list of common examples of oscillatory motion. Simple pendulum, swinging side to side. Vibrating tuning fork, its prongs move back and forth. Spring mass system, a mass that bounces up and down. Swing on a playground, classic oscillation. Oscillations of a guitar string, it moves rapidly to and fro. So one important fact for you again is, all oscillatory motions are also periodic. Again, all oscillatory motion are also periodic, but they repeat after equal intervals of time. But not all periodic motions are oscillatory. Let's see what that means. Okay, so let's quickly recap oscillatory motion with more visuals. Remember, it's a to and fro motion about a mean position. Examples that you can see here. Pendulum, it swings side to side. Swing on a playground, classic oscillation. Guitar string vibrates rapidly back and forth when plucked. These are all periodic motions because they repeat at regular intervals. So again, all oscillatory motions are periodic, but not all periodic motions are oscillatory. So let's look at some examples that are both periodic and oscillatory. These include simple pendulum. So it swings in a repeated back and forth pattern. Vibrating tuning fork, prongs moves to and fro very rapidly. Mass on a spring moves up and down around a fixed point. Swing. You push it once and it keeps swinging in an oscillating and periodic way. So these motions have a central or mean position. They repeat regularly over time. That's why they are both periodic and oscillatory. Now let's compare periodic motion and oscillatory motion to understand the difference more clearly. Motion that repeats itself at regular time intervals is periodic motion. Oscillatory motion is a type of periodic motion in which object moves back and forth about a central position. Revolution of Earth around the Sun, ticking of a clock are examples of periodic motion. Pendulum, tuning fork vibration, spring mass system are examples of oscillatory motion. Periodic motion can be circular, linear, or any path as long as it repeats. Oscillatory motion always involves to and fro motion around a mean position. All periodic motions may not be oscillatory. However, all oscillatory motions are periodic. So the key takeaway is all oscillatory motions are periodic, but not all periodic motions are oscillatory. For example, the Earth revolving around the Sun is periodic, but it doesn't go to and fro, so it's not oscillatory. Understanding this distinction will help you a lot when we study waves, vibrations, and mechanical systems in future in higher grades. So you must understand the basics of motion first. Now let's look at a very unpredictable type of motion, random motion. So in random motion, the direction and the speed of the object keep changing suddenly. There is no fixed path or pattern. Take a look at these animals, the dog and the cat. When they run around in a garden, they change direction and speed randomly. You cannot predict where they will go next. Other examples, a fly buzzing around a room, molecules moving in a gas. Random motion is not regular. It is not repetitive. It is just chaotic and unpredictable. Now here is something really interesting. Multiple motion. When an object exhibits more than one type of motion at the same time, it is called multiple motion. Let's look at some examples here. Here is a bicycle. So the bicycle as a whole is moving forward. This is translatory motion. But the wheels are spinning. That's a rotatory motion. So we have translatory motion of the bicycle and rotatory motion of the wheels. Electric drill machine. The drill bit spins, that's rotatory motion. And it also moves forward into the wall, that's rectilinear, straight line. So, one object and two types of motion happening at once. Real life objects often don't move in just one way. They combine motions, and that's what we call multiple motion. So, let's quickly wrap up today's session with a summary of the most important points we learned about motion. What is motion? Motion simply means a change in the position of an object over time. If something is moving, whether fast or slow, its position is changing, and that's motion. Types of motion, we explored 6 main types: translatory, circular, repetitive, oscillatory, random, and multiple motion. Translatory and circular motion. Translatory motion can be rectilinear, in a straight line, or curvilinear, along a curved path. Circular motion includes rotatory motion, spinning about its own axis, and revolutionary motion, moving in a circular path around another point. Oscillatory motion. This is a special type of periodic motion where the object moves to and fro around a central point. A pendulum, a swing, or a tuning fork are great examples. Multiple motion. Many objects in real life show more than one type of motion at the same time. For example, when you ride a bicycle, the wheels rotate. That's rotatory motion. And the whole bike moves forward. That's translatory motion. And that's your quick recap of everything we explored today about motion.